Hello, everyone. Good evening, and welcome all of you to this ninth episode of our project discussion series that we conduct live on YouTube. Also, welcome to those who will be watching this link sometime later from the internet. So, a very good evening to you also. I hope my voice is audible properly and the video is also visible. I hope, yeah. So today we are actually, you might see a different background, and also we are starting at a different time today because of some commitments. So this episode that you can see right now, we are doing it from our office. So I hope the voice and everything is all right. And if it is all right, we can start with our ninth episode. So some interesting topics coming today also, as usual. We will, in the first segment, we will discuss, I would not say a problem, but a query which often comes into the mind of structural engineers. We will take that query in our first segment. So let us start, and a very interesting discussion we are going to have regarding the problem or query usually faced by structural engineers. So let us start then. So this time we are going to focus on which structural system to be adopted for pedestrian bridges. Now, pedestrian bridges is a common architectural or structural, uh, I would say, a structure. It's a common structure that you quite often see in the urban landscape, or in the rural landscape also you quite often come across pedestrian bridges. Generally, they dominate your skyline, and they are quite important in the city's architecture, and also important for the smooth movement of people from one place to other. So these days, not only in railway stations where usually we could see pedestrian bridges, you also see them in city centers, you also see them in major road crossings, and mostly they are done in steel. So why they are done in steel? Because of the ease of construction, because of the quick fabrication and installation. So pedestrian bridges mostly done in steel. Now if they are done in steel, which system is an efficient system? That is what we are going to uh, discuss today. I have had this discussion before in our online courses also. So some of you might have been a part of those discussions that we have had earlier. But anyway, it's an interesting topic actually to discuss. So you can see some examples of pedestrian bridges, common types of pedestrian bridges. All these images have been taken from the internet. This is the newly inaugurated Atal Bridge on the Sabarmati River at Ahmedabad. Again, pedestrian bridges, commonly seen pedestrian bridges, small span, 15 meters, and simple configuration. Another bridge. All the images, as I told, have been taken from the internet, and all these are Indian cities. I think, except for the first image, all these are from Indian cities. So this is a Virendil type of bridge that you see, pedestrian bridge. Again, an image from, I think, Hyderabad. This is a unique bridge which has been done in bamboo. This was quite viral on the internet a few months ago. So this is a bridge done in bamboo. I think in Assam. Which city? I don't actually know. So, what are the common systems adopted for pedestrian bridges? You can have a truss system, you can have a arch system, you can have a suspension system. Cable stayed systems are also can also be used for pedestrian bridges. But today's discussion we will be doing mostly on the truss systems. Why truss systems? Because they are more common for your mid-span, mid-length of bridges that you often see in the cities. So our focus today will be on the truss type of bridges. So what are the common truss type of bridges that you see? So this is called as an N type or a Pratt type of truss bridge. This is called as a Hove type. I call this also as an N type, but I think I saw in the books they have written it as the Hove type or Hove type of bridge system, truss system. This is a Warren truss. This is a K-type truss, and this is a very unique shape that is not quite often covered in texts or does not come across in discussions. This is called as a Bailey's type system. So we are going to discuss these five types of systems that you can quite often see for the truss type of bridges, and we will compare and see which system seems to be better. Anyone thinks, or which system, can anyone tell me which system might be more efficient? I can show you once again all these five. Which of these you see, you have seen more? A, B, which of these systems do you see more? C, D, E. Yes, anyone? In their cities, in their towns, or wherever they are coming from. So I think most commonly seen system would be this type of system that you most commonly see. The Pratt type, yeah, the Pratt type is most commonly seen in the cities or urban spaces. Warren type, not very common, I would say. Pratt type is the more common system that you come across. Oh, two of them have said Warren type. I mean maybe, but where we live, we don't quite often see warrant type being done. Okay, good. So let us see what comparison we will be doing for this. So yeah, so we are going to take a standard span of 45 meters, and the height of the truss bridge will be taken as 4 meters. The sulfate we will take as sulfate will already be considered by the stat software. Uh, in addition to the sulfate, we will take another load of 1.8 kilonewton per meter, and we will also take a live load of 9 kilonewton per meter. So that is what we are going to take, and that is what we are going to uh, have for our comparison. I'll just give you a minute to think on this, and let me just, yeah, give me a minute. I'm actually trying to come up with. Yes, just give me a minute. Okay, good, very interesting. So this is how you will find these systems. We have made them. We have done a quick sketch. Sorry, we have done a quick model on the software, and you will see all these systems being developed. All the five options, I have given them A, B, C, D, and E. All are 45 meters length and 4 meters in height. And as I told you, the loads have been applied, standard loads have been applied, standard properties have been taken. So the top chord and bottom chord is ISMC 200, uh, back to back, having a spacing of 175 mm center to center. Weber is saying, how is the spacing between members decided here? Okay, I will discuss. Wait. Then we have taken these diagonals and initial verticals and diagonals. We have taken them as ISMC 150 back to back double channel. Then the middle diagonals and the verticals, we have taken them as ISMC 125 back to back, and then the central portion, we have taken them as ISMC 100 back to back. So you will see properties we have tried to keep uniform. Okay, ISMCs for the top chord, bottom chord, ISMC 150 double for the outer diagonals, verticals, then 125 followed by 100. So this is what we have taken, and then we run our analysis, and these are the analysis results that you are getting for for the 1.5 dead load plus 1.5 live load. Now over here, I must tell you something and a few points to discuss before we move to the next slide. This brown color that you see represents compression, and the blue color that you see represents tension. So this is for the gravity load. Therefore, the top chord is in compression, bottom chord is in tension. Okay. Also, you will see compression tensions in the diagonals and the verticals. So I given them names A, B, C, D, E for quicker discussion over here. Okay. So what is the difference that you see in type A and type B? If anyone can observe and tell us. So the difference between type A and type B, the forces in the top chord, bottom chord are almost same magnitude wise, but what about the diagonals and the verticals? Do you see any difference in the behavior? So in the type A, if you look at it, there is tension in the diagonals. All diagonals are in tension. And if you look at type B, all diagonals are in compression. Okay. Why is that happening? That is happening because of the shape of this assembly, or because of the shape of this configuration. So if you do not have any chance of load reversal, and let's say there are no wind loads to take care of, or there are no wind loads to think of, then only for gravity loads without load reversal, A or B, which will be better? Yes, tell me. Amongst A or B, if there is no chance of load reversal, or if there is no wind loads to think of, there is uniform load on the bridge, then which type, A or B, will be better? So in that case, type A is much better because your longer members that are the diagonals are in tension. Okay, diagonal members being in compression is a problem if the members are long, because you know that if members are long, there is a problem of slenderness. So that is the difference between A and B. You can visually see this quite well. Uh, you can visually see and understand this quite well, I believe. Yes. What happens in C? Quite interesting. What is happening in C? Or before that, let's go to D. So in D, there is an alternating compression tension in your diagonals. In type D, Warren truss, there are no verticals, so the compression tension is alternating between the uh, there is compression tension alternating in the diagonals. What about type C? So if you see the type C, that is the K type. Now every set of diagonals is having compression. So the top diagonal is having compression, the bottom diagonal is having tension. So within a set, you are getting both compression as well as tension in the diagonal. That is the K type. And then the last we see is the Bayes type, type E. Here also you are getting alternating compression tension in the diagonals. Okay. So if load reverses, let's say there is a load reversal in A, maybe due to wind or due to some other factors, then there will be tension or compression in type A. So in case of load reversals, type A diagonals will come under compression. Okay, in case of load reversal, that load reversal may be due to wind or in some cases due to moving loads. All right, so that might happen in type A. So there is always going to be a problem of load reversals in A and B. If you see types C and E, there is not much issue of load reversals. I hope you understand, because even if there is load reversal, you have got similarly long chords and similarly long diagonals to take the compression or the tension. Let us move ahead. Let us see their magnitudes. So if you observe, as I told you, the loads are similar, or same loads have been applied, not similar, same loads have been applied. So what do you find? I have just written down the maximum compression and maximum tension in the top and bottom chord. So on your right side, you can see them. I have also mentioned their lengths, length of each member. So you will see it's almost similar. There is not much difference. Almost, I think 14, 15 kilonewtons over here and there, mainly due to the difference in self weight. Otherwise, almost all the chord forces are same. So what I'm trying to tell you over here, that chord forces are same, then what will be the governing criteria? So the governing criteria will then become the length of member. All right. Why length of member becomes the governing criteria? Because if your member is long, then the slenderness ratio will be high and the compression capacity will be less. All right. So even though the forces are same, but because of different lengths of the member, their capacities will be different, and therefore the utilization ratio will be different. All right. I hope you are getting this point. So that way, if you see, this Warren's truss seems to be quite poor because it is having the largest length of 3.6 meters. You get it? So that way, if you understand, Warren truss does not seem to be quite good in this case. If I go to the diagonals, what do I see? Again, in the diagonals, I have just written down there tensions or compressions, and if there is both, I have written down both. Okay. Now, if I ask you which type seems to be better, if you just compare the forces in the diagonals, see, because top chord, bottom chord, you are having similar force, same force. So that was not a differentiating criteria as such. Now, if you come to the diagonals, there is lot of difference that you see in the values. So which type you think is a better type just by looking at the magnitude and the length of member. So type C and type E seem to be the better types. Why? Because if you see, the length is 2.69 meters, so length is small, and even the diagonal forces are small. So you are having 282, 279 as compared to 438, 445 in the type A and type B. So that way, if you understand, K type, that is type C, and the Bayes type, that is type E, seem to be better. Okay. Yes, C and E seem to be the better types because of the less magnitude, also because of the lower length. Very good. So smaller length, that's what I have written. Smaller length for member in compression is better, as the slenderness ratio for small members will be less and capacity will be high. The tension and compression in the member may undergo load reversal in case of moving loads or wind effects. So wherever there is a chance of load reversal, and if you have diagonals like type A or type B only in one direction, that will be a problem for you. Okay, good. Let us move ahead. Okay, so which option do you think is better? Before moving ahead, which option seems to be better? Arre, no one thinks any type is better. Yes, C and E seem to be the better type right now. C and E seem to be the better type, which is C, K type, and Bailey's is type E. Let's move ahead. Let us compare the deflections. So till now we compared the ultimate criteria. Now let us compare the service criteria. So what I have done is I have just highlighted the nodes at which we will be checking deflection for the service load, and these are these are the deflection values on your screen. Okay, so type A, type B was giving you higher deflection values. Type C, the K type truss, is giving you, I think, the least of all these. And type E is also quite near 77.95. So type C and type E are giving you the least values of deflection. A and B are giving you higher values as such. All right. Oh, so before going ahead, which option do you think is better? Again, if I ask you. So we have compared the deflection, we have compared the ultimate criteria. So type C seems to be the better type. Okay. So as I have highlighted, the K type and the Bailey's system seem to be better suited types for us. All right. Yes. But then let's see more of it. Let us see more of it. But very important, Bailey's system scores more due to the modularity and the option of repeatability and stackability. This is not a word, but I have just written it. Stackability. The stackability would mean the ability to stack these modules one over the other, or the ability to keep these modules side by side. So in Bailey's bridge, this is a typical module which you can use as a building block, or which you can use as a block, and you can repeat it to create different configurations for different spans and loadings. Quite interesting. Let us see how. So, for example, this is the bridge, but will it work for a 65-meter span? What do you think? Till now, our span was 45 meters. Will the same configuration work for uh, will the same configuration work for 65 meters also? Same configuration. Same configuration means the same ISMC 200 in the top chord, the same ISMC 150, 125, 100 for diagonals and verticals. So will it work for 65 meter span? Till now we had taken 45 meters of span. So if your span becomes 1.5 times, your bending moment becomes how much? Oh, it should not have been written 4 times. It's a mistake. How much your bending moment will become if my span becomes 1.5 times? So my bending moment will become around 2.25 times. Okay. Please ignore this 4 times that I have written. It will be 4 times when my span doubles. If my span is becoming 1.5 times, my bending moment will become 2.25 times, square of the change in span. So certainly this same configuration that we were using for 45 meters will not work. Okay. Will not work. Then what will work? Sandeep is saying to revise the sections or change the spacing. No, but my insistence is to use this same module. I don't want to change this dimension because I want to repeat it in my configurations wherever a chance I get. So I don't want to change the spacing. I don't also want to change the member. I don't want to change anything. But what I can change is I can change the configuration. So how do I do that? So I uh, involve the ability of this system to repeat itself or to stack itself one over the other. So what I do now, very interesting, I apply a two-tier Bailey system. Can all see this? So the basic module still remains the same, but it's a two-tier. All right. So 65-meter span, earlier it was 45 meters. So now my span has almost become 1.5 times. my bending moment has doubled up. So the chord forces will naturally double up. So therefore, I have provided two tiers of Bailey's system over here. Okay, will it work? Let's see. So now when I do the analysis for the same loads, that is 1.8 kilonewton per meter finish load and 9 kilonewton per meter live load UDL, then you see the top chord and bottom chord compression tensions, and you see the diagonal forces compression tension. What you see, the maximum chord is 1407 kilonewtons, tension it is 1389, and the diagonals, very important, they still remain the same. I don't know whether you had observed earlier, when we had a 45-meter span, one tier Bailey's bridge, you see the diagonal forces. And now when I have a two-tier Bailey's bridge configuration, 65-meter span, still they remain the same diagonal forces. You see, the top chord, bottom chord forces are changing. The primary reason is because due to increase of self weight. Otherwise, if you just check for live loads, the top chord, bottom chord forces will also match for a 45 meters belly or for a two tier double deck belly. So that is the advantage of belly that you get, that you can actually design a belly's module and you can repeat it, you can stack one over the other, and you can use them for multiple configurations. Okay, so this uh, I will say this flexibility and freedom you do not get in the K type. Okay, so the K type bridge does not offer you this flexibility which Bailey's bridge offers. Another important point that you should understand over here is the ease of connections. So if you have this type of a Bailey system, it becomes very easy to connect all these diagonals together. Why? Because all these compression tensions in the diagonals will be counter balancing each other, making our connections very light. Okay, so even our connections become quite light where diagonals are getting connected, and this entire system is an excellent system to be repeated and to be used for different loadings for different configurations. Okay, so in this way, if you design this properly, you can use it for, as I just said, different loadings and different spans, and good for load reversal also. Yes, as Mega is saying, it is good for load reversal also because you have the diagonals to take care of, diagonals in both directions you have for load reversals. So this Bailey's bridge system is an excellent system, and I would personally recommend it to be used in pedestrian bridges. Very efficient system. But where have you seen this type of a system anywhere? Has anyone seen it anywhere till now? Yes. If you are good observing structural engineers, you must have seen them somewhere. As a structural engineer, we should also be very good at observing things. Yes, no one has seen it anywhere in the built environment. That is quite strange. Have you seen such type of bridges anywhere? Those who uh, live in the hilly areas where the border roads have to construct a lot of infrastructure, or in the northeast parts of India where the border roads do a lot of infrastructure, hilly terrains, you must have seen this. Yes. So this is called as a uh, Bailey's bridge system, and here what you see is a two-tier Baileys. If you see one on the top of other, so this is a two-tier Bailey. I have taken some pictures from the internet. Uh, Oves is joining us from Kupwara, so I welcome him on this episode today. Yes, so when I have shown you the pictures, you can recollect having seen these. If you see this third image, you will notice that the two bellies have been stacked adjacent to each other. So with belly, you have this flexibility. You can stack them adjacent to each other, and you can stack them one over the other. All right. So this is the advantage that you get with this modular system, and they are quite often seen in the northern and the northeastern parts of India. But these days, I don't know why you don't see it in the built environment, in the city environment. In cities also, these should be built because of the flexibility and because of the repeatability that they offer. So to conclude, I would just say that this system is efficient, quick to build, and it can be, in my opinion, it can be used for making bridges in the urban spaces also. So this is what I had to say about efficient bridge systems, and I hope we get to see more Bailey systems being adopted in the cities and town centers also. Why this name Bailey? Because during the World War II, this Mr. Bailey was a British engineer who came up with this system, and then he, I think, applied for some patent or something, and he got this in his name. So it is still called as Bailey system. So this was his last name, I guess. Bailey was his last name. A few years ago, you had a captain of cricket captain of Australia by the last name of Bailey, I think, George Bailey, cricket captain of Australia a few years ago. So with the same last name, this was Mr. Bailey. He was also a civil engineer from the World War II times. Anyway, very interesting. So this is what I had to say about the bridge systems that you can adopt. Uh, could you please share? Vijay Kumar is asking. Could you please share the self-weight of that all the option to get the economical view? Yes, with respect to economy, C and E will be more economical. The type C and type E will be more economical with respect to the total tonnage or the total consumption of steel. Good. So I think we had this interesting discussion. Ashish is saying instead of back-to-back channel, face-to-face channel will be more advantageous in your example. Question mark. But back-to-back channels actually give you a ease of connection. Okay, so when you put channels back to back, it's easier to connect them, especially for the top and bottom cord. So I will have my top and bottom cord, and then when I want to connect, let's say the verticals or the diagonals, having a back to back arrangement will be easier for me with respect to connections. Yes, with respect to strength, front to front will give you more strength because it will give you a higher radius of gyration, but back to back offers me better connection capabilities. Good point. Okay, so this is what I had to tell you about the bridge systems. I hope it was an interesting discussion that we could conduct. So if there are any questions, we can take them later after I finish my second segment, and that is a discussion on the project. So, as you are aware, we try to take up some project related queries, queries from some actual projects, and we try to discuss them. So, in today's episode, we have taken, it's not actually a project, but it is a discussion on understanding the inputs and specifications required for pre engineered buildings. So, you see many pre engineered buildings these days. But many times, as structural engineers, we struggle to understand the inputs and uh, the specifications required for design. So let us understand that, and I'll just tell you what are the important inputs and specifications that you should keep in mind when you are doing any pre-engineered building. Here, I'm going to focus more on pre-engineered shed, industrial shed type of structure. So here you see a typical plan. You can see a typical plan over here. This is a typical elevation. So you see there is I mean, there is an extension. So the plan is L shaped, and In the extension, they have given a lean to roof monoslope system, and you have a main, uh, what do they call, pitched roof system in the other part. So this is one elevation where you see the extension in the monoslope, and you have this central portion with the dual slope. These are just the elevations. So how to collect inputs and specifications. So suppose you are a structural designer and you go to the client, then how to collect the inputs and how to collect the information and specification required from the client. As a structural engineer, I have quite often seen that we are quite poor in understanding the inputs required and understanding the specifications for any structure. And many times, because of our poor understanding, we uh, get into a lot of rework and troubles, and finally our structural cost and design suffers. Okay, so it's very important that you ask the right questions from your client and get as much as inputs possible and specifications for the design. So, what are the inputs that you would like to collect? It is always good to prepare some type of a questionnaire and ask questions to the client and collect the information. First is usage. Of course, I need not stress on this point more. We all understand that use understanding usage of your structure. Here I am talking more about the industrial shed. So understanding usage of your shed is quite important. So always ask that what will this shed be used for. Understand the basic dimensions, the width, the length, the eaves height, the slope, roof slope. Generally, in pre-engineered industrial shed systems, these days it is kept at 1 is to 10. The ridge height, automatically you will get the ridge height if you have the eaves height and if you have the slope. The column to column spacing, you will, if you are into doing industrial sheds, you will see these days what spacing is followed mostly. What is the common spacing people like to adopt? So the most common spacing that people like to follow, column to column spacing in industrial sheds these days, pre-engineered, is around 7.5 meters. Okay, and why this 7.5 meters? Because of the optimization of purlins. So your purlins get optimized, and purlins add to a lot of weight of your consumption. I would say purlins have a lot of steel consumption. So if you are able to economize purlins, you are able to economize the project overall. So 7.5 meters is a good spacing to have. Earlier, when you did not have the cold forming techniques, then you had to go for hot rolled purlins. In those days, around 5.5 meters was the standard span that people used to keep column to column spacing. But these days, with the cold forming, cold rolling available, you can go for a 7.5 meter span quite conveniently. Okay, so always ask this question. Then, very important, always understand from the client whether there will be any future expansion in the, I mean, do we need to keep any provision for future expansion? Just like when you are doing any RCC building, you always ask whether any additional floor has to be constructed. Similarly, always ask whether there is any requirement of a additional or future expansion. How will it affect? So for example, if you see the gable end, if there is a future expansion, then your gable becomes what? So gable becomes the internal frame. I hope you are able to understand gable, internal frame. These terminologies I hope are clear with you. So if there is future expansion in any direction, the frame which was gable may become what? May become internal frames after expansion. So your gables also have to be designed so that may become uh, they may become internal frames in the future. So this question is very important, that will there be any future expansion or any provision has to be kept for future expansions. So always take this data from the client. Very important. What loads to consider? Of course, dead loads, roof live loads, wind, seismic, that anyway we consider. but ask about the collateral loads. What is the meaning of collateral loads? So in the pre-engineer terminology, collateral loads means loads other than what I've listed above. They are sort of uh, what should I say, superimposed dead loads. Okay, so those may be due to service lines or air conditioning ducting, or maybe due to any equipment load, any solar panels, or anything other than the loads that you have considered. Any other load, if it is possible that your structure may have to take, you must always ask your client about it. Okay, very important. Then cranes, again, very important. From the usage, you will understand whether or not cranes are required in your industrial shed. And if there is a crane required, what capacity of crane, whether it is a 1 ton, 2 ton, 3 tons, 5 tons, 10 tons, 15 tons, 20 tons, what capacity of crane, which type of crane, whether it is a monorail or it is a double, what do I call, gantry type of a crane, or whether it is to be suspended from the roof, or whether it is a jig type of a crane. So all these questions have to be asked. What is the type of crane you want? Whether there is one crane or multiple cranes in big sheds. Your client may ask for multiple cranes. If there are multiple cranes, what will be the type of operation? Will it be a single operation or operation in tandem? All these things also you have to understand and ask. Okay, quite important. Side cladding, again very important. If you have seen industrial sheds, generally in the sides you have a brickwork till a certain height. Why do we take this brickwork till a certain height? Because generally there are some civil constructions done till certain height. You may come up with toilets, or you may come up with some internal rooms, and also for better heat insulations. Generally, it is a practice to have certain height of brickwork, and then you give cladding. Okay, so you should always ask that for side cladding, whether you want brickwork till a certain height, and after that what type of sheeting you need. Generally we provide 0.5 thick color coated galvanum sheeting. That is a standard cladding that is provided. Also understand in roofing what is going to happen, whether or not there will be any insulations. Generally insulations are provided for temperature control. So understand what specification of insulation will be provided. Generally, you may come up with glass wool or fiberglass wool, or there are a lot of insulations. Thermocols are also used in insulation. So always understand what type of insulations are going to be provided. This may add to your load actually, but nothing much with the structural viewpoint. But here we are trying to take a bird's eye view of all the inputs and specifications of a industrial shed. Whether or not skylights, turbofans, ridge ventilators are required. Skylights, what are skylights? They are transparent or semi-transparent panels made out of polycarbonate sheets to give you good light inside the shed. So, what area of skylight is required? You should ask. Generally, we provide around 4 to 5% of the roof area as transparent sheeting. Turbofans for proper ventilation and for proper air exchange, we provide turbofans. So, how many turbofans are required? You should ask your client. It also depends on the area of the roof. Ridge ventilators, again for proper heating ventilation, you provide ridge ventilators on your ridge. How much to provide? Generally, every alternate bay we provide it. So here, if you see a plan, you will see these hatched portions are my what do I call them? Transparent panels, skylights. Then you will see small squares. These are my turbofans. And in the ridge, you will see a ridge vent. So all across the ridge, we provide a ridge vent, and those vent installations we do in the alternate base. So the vent ridge, I think it's called a ridge monitor. So ridge monitor goes along the ridge line, but mechanical vents we will provide every alternate bay. That is the usual practice that is adopted. Openings. whether or not you will require any openings at gables. Will you require any openings at doors and windows? What openings will you require? Will you need openings for rolling shutters? What will be the size of rolling shutters? In fact, rolling shutter is so important that we could have a half an hour, 1 hour discussion just on the rolling shutters that you have to provide in your industrial sheds. Canopies. Here I have missed canopy, but canopy again is very important element in your industrial shed, and it also affects our design. Why we may have to give canopies in our industrial shed? Because we have to cover these openings. Okay, so we have to provide a cover against rain, cold, for our rolling shutters, for our doors, windows at the gable ends. So canopies are also very important. Generally, the openings, door window openings, rolling shutters depend on the client requirement, but this input is actually important for the structural viewpoint. So always ask about this. Always ask about canopies that you have to provide. Canopies also become a very critical element in the overall design of your industrial shed. So here I have tried to show you some openings. This is a typical elevational opening, I think, for rolling shutters. You see, sometimes you have to provide large openings and you have to design it accordingly. Then some miscellaneous requirements. Gutters. What is the type and size of gutter required? Generally, it depends on the rain intensity and the roof area. This is one place where almost all the pre-engineered sheds fail. Fail means in every rainy season you will see that your shed is leaking. Why it's leaking? Because of the Why it is leaking? Because of the improper gutter size and because of the improper downtake pipes. So downtake pipes take the storm water, rainwater from your gutters to the stormwater line on the ground. So the junction between gutters and downtake pipes leak, or that junction is not done properly. So almost all the sheds you go, there's always this problem about the gutters and the downtake pipes. So it's very important that you provide proper sized downtake pipes, proper sized gutters. Generally, we provide a 110 dia uh, downtake pipe, and the gutter depends on the type of your shed. It also depends on the rainfall intensity. We also on the roofs provide safety items like ladders to climb up to your roof. So the maintenance personnel will climb up using a safety ladder or a cat ladder. So that cat ladder has to be properly designed and provided. We also provide a safety line. So safety line is nothing but a sort of a railing with a wire rope where you can tie your harness. Okay, and then your maintenance people can move on the roof. So these safety lines, ladders for access should be provided. These are some miscellaneous requirements. So overall, these were the main inputs and main specifications you can ask from your client before starting the structural design. Okay, if you get all these inputs properly, it will help you not just in the process of design but also in the process of drawing development, fabrication, erection works. I have seen in most of the projects there is always dispute in the projects, mainly because the specifications were not clear and the specifications were not properly understood. So it's very important that all these inputs and specifications are taken before the start of project. Good. So I hope this was an important and an interesting discussion. Okay, good. How long cold form sections available in market? It depends on the section size. You can have it around 6 meters, 8 meters. It also depends on the transportation arrangement. So generally, this has to be transported using trailers. Up to 12 meters, if you have long sections, you can have them. Generally, it would be around 6 meters. Okay, good. Ashish ji is saying should be considered lower areas while calculating percentage of openings for calculating CPI. Very good. So CPI, in our wind calculations, the internal pressures are calculated on the basis of openings, walls and doors. What are louvers? So for those who do not know louvers are actually adjustable openings which you can uh, open and close, just like you have in toilets. If you go to your toilet, you will see a glass louvers that we provide. So similar louver arrangements are provided in the industrial shed also. So his question is, should we consider the area of louver in calculations of CPI, because these louvers are adjustable? We can open these louvers, we can keep them closed. So should we consider the area? I don't know. I mean, I personally don't calculate it, lower area. Why to unnecessary calculate higher CPIs? Okay, but yes, this is a subjective question. Uh, you may take it, you may not take it. I don't take the lower area in openings. Very nice. So this is what I had to tell you about the inputs and specifications for a pre-engineered shed kind of a structure. And now we move to our third segment, where we invite young structural engineers and we try to understand and learn from their experiences. So for this episode, we have a young engineer Parth Tokekar. He is a postgraduate in structural engineering, and currently he is working as a structural design engineer at JW Consultants, Pune. So it's a well-known name. I hope all of us have heard about it. And he is currently involved in design of commercial, residential, multi-storied, and tall structures. So he would be talking to us about his experiences, and mainly he would be also focusing on how uh, non-IIT, non-NIT engineers can apply for and can work in big consultancy firms. So we welcome him. Hello, good evening, Parth, to this
Good
episode.
evening, sir. Good evening,
And
everyone.
yes, and thank you for taking out time.
No problem, sir.
Yes. So if you could tell us your journey till now, after you did your BE, what all things you have done till now, if you could
Yeah,
tell that.
so I completed my bachelor's in civil engineering in 2018. So
Yes.
after 2018, I had an year gap, and in 2019, I joined in Masters of Structural Engineering in SGSITS Indore.
Okay.
So after 2019 I joined, and in 2020 there was lockdown due to Corona.
Acha.
So due to that, it had a large, you can say, big effect on my post graduation. And in 2020, I started teaching online, and it was a bit on and off thing. Before
Okay.
that, I had also joined Ashutosh sir's offline class for that, so it helped me a lot. After I finished my post graduation in 2021, so I started my first job at RKGA Consultants Indore.
Okay.
So mainly RKGA is an architectural firm. So in an architectural firm, most of the projects are, you can say, most of the projects were mid-rise buildings, G+5 mostly, and residential buildings. So a lot of work which was being done was in on architecture side, and I was the only structure engineer there. So whenever
Okay.
anything new was being implemented, so I was asked beforehand that would this be feasible structurally or not. So
Okay.
I had a big, you can say,
Responsibility.
yeah, responsibility as well, that yes or no was from my side. So that was a big thing when I joined. So it was an altogether different experience when we are designing something theoretically, and when we are actually designing something. So I had two draftsmen with me as well. So draftsmen would ask a lot of things about small detailing in drawings, that how should we detail this, how this should be detailed, how this drawing should be prepared. So
Yeah.
that is an altogether different experience, because theoretically no one works much on drawings and everything.
Yes.
So for that, I needed to refer a lot of IS codes and everything.
Yeah.
So
Yes.
during that time, I learned a lot about detailing. So this helped me a lot later on when I joined JW. Also, when we are working in an architectural firm, so it is a more emphasis on architecture and not much on structure. So that was a
Yes.
bit downside of working there.
Right.
After leaving RKGA in August 2022, I joined JW Consultants in Pune. So I am working here as a structural design engineer since last 6 months. And
Okay. So, what are your
yes,
current roles and responsibilities at JW? If you could talk a little louder.
yeah, can you hear me now?
Ha, nahi, your voice is audible.
Okay.
Yes.
So currently my role at JW is structure design engineer. So in my the regular responsibilities are to design and detail structures. But apart from that, there JW has a very specific, you can say, system where projects are assigned to project leaders, and from project leaders they are transferred to us. So based on that, I have some projects which I have to work on.
Okay.
And working at JW is altogether different experience from what I was doing earlier, because mostly at JW we are involved in a lot larger structures than what I was working on before. So
Correct.
here more stringent deadlines are there and more pressure is there. So that is a altogether different experience. Apart from that, I have to sometimes attend meetings offline and online, and client
Yes.
interaction, as well as I interact with architects and prepare GFC drawings. So that is all in all I have in my daily schedule. I have to
Okay.
work on all these things.
Okay. No, so the important thing why we thought we would invite you is if you could tell us that as a non-IIT or non-NIT graduate, postgraduate, how to, because that is your journey and you joined a big consultancy firm in India. So
Yes.
if you could tell us and share your experiences that how uh, engineers who maybe have not uh, done their degree from a reputed NIT or IIT, how should they uh, how should they work towards joining big firms? If
Okay.
you could tell us
So
about that.
yeah, can I share my screen?
Yes.
So yeah, I hope that my screen is visible.
Yeah, yeah. Yes.
Yes. So if we talk about a person who is from non-IIT or non-NIT background, so the first thing is that whenever anyone wants to enter any reputed civil engineering firm, it is very difficult if you are from such background. Why? Because if we see, first of all, that we have to apply through off-campus placements. So whenever we are applying through off-campus placements, we go through a much more stringent scrutiny than what is being done on campus level. So that is a very big thing when it comes to off campus placements. Apart from
Yeah.
that, another big thing is that resume shortlisting. So if you are from IIT or NIT, so most of the people go through this resume shortlisting very easily, because if there is an IIT or NIT tag in your resume, so your
Yeah.
resume gets shortlisted very easily. But if you're not from IIT or NIT, so a big hurdle for you is to cross that resume shortlisting. So if
Yes.
you, because many people who are not from IIT or NIT, but if they go through resume shortlisting, they can definitely crack further rounds. But most people, like, resume shortlisting becomes a very major hurdle to cross. So
Correct.
all these factors make it much
Roadblocks.
more difficult.
Yeah.
Yeah, all these are roadblocks when we talk about joining a engineering firm which is reputed in, or we can say that in joining a core company. So what
So
I'm
that
going
is
to do is
directly from the college. That is joining difficulty in joining directly from the college.
yes.
Okay. Yes,
So
please continue.
what I'm going to do is I'm going to go through all the process, like because the process is that first you apply for any company, then you are shortlisted, then you go for written or interview,
Ah,
and how should you prepare for an interview. So first of
yeah.
all, when it comes to applying for companies, I would say that the first thing which they see is your resume. So whenever you are applying as a student or as a job seeker, so we should you should upload you should update your resume time to time, and you should update your resume at regular intervals, and write whatever you have done as a freelancer or any particular course you have done. So that is an important thing, because whenever someone opens your resume, because he has 2 or 3 minutes, let's say maximum 5 minutes. So if you have written something important, like present you are presenting your skills in a very structured manner, that
Yes.
whichever skill is required for the job, so that would be much more important than adding something like extracurricular activities or unimportant achievements, like finishing first in this race or that. So that I think is very important, that we have a very updated resume, it is well structured and everything. Apart from that, whenever you are applying for any companies, so you should directly apply from the website, because website is a very structured layout, that what role they are looking for. Apart from that, they have that what is the expected salary, what is the salary they are offering, and everything, that what experience they require, any particular software they require for that role. So that makes it much more easier for us to shortlist, that whether we can be shortlisted for this
Um,
role or not.
if we are a good
And
fit
if
for the role or not.
yes, so that is a very major thing, because if you are applying for, let's say, 100 jobs, so 100 jobs, it would take your time as well. And apart from that, if you are not seeing properly that what are the profiles which are required, or what are the roles being offered, so that would be a waste of time for us as well. So that is an important thing. Apart from that, try to know about the selection process beforehand, that whether interview would be conducted in the office or it would be conducted online, whether it would be conducted whether there would be written or not. So that also makes it easier. Let's say that the interview would be conducted in the office, so if you are not
Uh,
able to go to office, the what is the sense of applying and going through such a rigorous process?
yeah,
So
true.
that I think is important when you are applying for a particular role.
Correct. So due
Next,
diligence should be done before applying. That is what you're
yes,
trying to say.
yes, both to save our time as well as company's time
Their
as well.
time. Yes.
Yes. So when next it comes to selection process, so I will talk about selection process for JW, and then I will talk about selection process in general. So in JW there is first of all a written test. So written test is mostly about SFD and BMD, and basic questions about design steps for slab beam column footing. So then after that there is a software test. So software test for ETABS, and if you clear the written as well as software test, so you are eligible for the interview. Apart from that, if I talk about other companies, so some companies I know conduct a very comprehensive written test of 3 hours.
3 hours.
So yeah, so that is like a gate paper that you have to
Yeah.
theory and everything. So that is a very, because not many people prepare for such type of test. So if you know that such type of test would be conducted, so it would be a big plus. And if we talk about written test, mostly the companies have like ask SFD and BMD for beams as well as frames. So I
Yeah.
have underlined frames because most people easily do it for beams,
Uh,
but our frame it is much more difficult.
correct.
And after that, one method for solving indeterminate frames. So sometimes
Mm.
there could be a random question about indeterminate frames. So if you know one method, so you can easily solve it.
Uh,
And design steps for slab beam column footing, that is an obvious when it comes to any company interview or written. And IS code clauses related to design and detailing, so I would include 456 IS 800 1893 13920 875 part 3,
uh,
because all these are very extensively used in design of RCC as well as steel structure, so it is important to know all the basic codal clauses related to
correct.
design and detailing.
Yes.
Next would be what to expect in an interview. So if you are eligible, if you clear the written test, so mostly interview is technical and very as far as I have experienced and I have listened to other people, so it is very less emphasis on HR and other topics, but interview is mostly focused on technical aspects. And what role is being interviewed for. So if we say that it is for RCC or steel or any particular type of structure, then that structure would be obviously asked in detail. And what have you written in your resume? So most sometimes the interviewer also has your resume, so he or she can ask about various things you have written in your resume, like your internship or any particular project you have worked on. So
Yeah.
that is an also important thing when it comes to interviews.
Uh,
IS code clauses and basic design and detailing fundamentals. This is an obvious when it comes to interviews. And sometimes SFD and BMD for beams and frames in interview as well. That
अच्छा.
they can ask on a on a piece of paper, draw SFD and BMD quickly. So in interview as well, it is important that you are well prepared, that
Yeah.
beams and frames SFD and BMD can be asked. So
Mm.
this was an overview that if you are clear the resume shortlisting, then these two steps would be waiting for you next in any company. So I think that most of the people are well prepared for, let's say, interview, but very less people are prepared for written.
Yeah.
So that one thing you can focus on is that prepare very well for written tests. Uh, yeah, apart from that, my suggestions for non IIT and IT engineers who are doing their post graduation would be that work and study super hard in your initial days. Because if we see that if you are working on a G plus 30 structure, which is a normal building structure, residential, let's say. So in that you need to know foundation design, water retaining structures, retaining wall, tall building code, shear wall design, reasonably good knowledge of earthquake and wind. And apart from all these things, you need to know software as well, and limitations of software,
Yeah.
that what particular things you can rely on software, and for what particular things you need to check manually, or you need to double check in software that whether your inputs are right or not for anything unusual results you are getting. So these are the things which you need to know only for a building structure. So if you
Yeah.
talk about any particular industry, like let's say oil and gas, steel structures, industrial structures, as we were discussing before, PEB
Yeah.
structures. So for all these things, we can imagine that how much knowledge we need to have if we are working as a structure engineer. And apart from these, what I would say is that working as structure engineer is a very responsible job, because you are responsible for life of so many people. So
Yes.
that also makes it a very critical job. So this would be my first and most important suggestion, that work and study super hard during your initial days when you are
Yeah.
post graduating.
I think
Apart from
during
that,
post graduation, you have a lot of time at your hand. I mean, there is a lot of time to experiment. There's a lot of time to spend learning things. There's a lot of time that
yes,
you get during post graduation.
yeah, because in I think in most colleges, second year is for the thesis, and first year
Thesis.
also the classes are not that much, like 11 to
Yeah.
4 or something like that. So people in post graduation have a lot of free time as well.
Free time. We used to only swim during our post graduation, so we wasted all our time doing swimming. Yes.
Okay, so next suggestion would be that take every opportunity seriously, because as a civil engineer, we all know that in this field, very less opportunities are available if you are from non IIT or non NIT background. So if you have any opportunity, go for it with 100% of whatever you have. And if you are currently studying, so in that case you can ask your professors, because professors have projects. They can have some projects from government, or they can have some projects for peer review from consultants as well. So they
Yes.
have projects which they can assign to you. So this can help you a lot in basically having an introduction to working professionally. So
Yes, I think
this
this is an important point that you have made, that almost all the senior professors in colleges have some consultancy project that they are working on. And if you are an
yeah,
eager student, the professor will be very interested in giving the opportunity to you. Yes. Very true.
Yes. Also, some of the professors may have their own consultancy, so that may be a big plus for you. That if they assign some projects, so and
Yeah.
also they are there for guidance as well. So you have
Yeah.
responsibility, but you have guidance as well. So both of these things can help you if you are very, like, if you really want to get into design.
Yes.
So these two things would be my suggestions for someone who is doing post graduation or is seeking a job. Apart from that, my takeaways at GW would be that scale of the project. So first of all, many people think that
How long
scale
have
of
you been working? Just to interrupt, how long have you been
uh,
working there?
at JW I'm working for 5 months.
Acha. So this is your till now what your experiences at JW. This is what you are telling us right now.
Yes, that
Okay,
from
your
my
takeaways.
experience, yeah, that at JW, and comparing it with my previous job as well as comparing it with what people say. So
Okay.
when I talk to people, so most people say that during initial days it is important to work on big projects or something like that. But after coming here, I understood that scale of the project is not that much important as having basic basic concepts which are clear. So if you have good basics, so in that case you can work on project of any scale. If you have very large project, so you would need some time to adjust, but you won't need to start from zero. That, let's say that you are designing G plus 10, and sometimes, and at time you have a G plus 30 structure, so you won't need 1 year 2 years to jump from G plus 10 to G plus 30, because you have very good fundamentals and everything, and you
Yeah.
understand the behavior. So
Yes.
if the scale of the project increases, it does not drastically change many things if your basics are good. And with software, so yeah, with softwares you have so much data available that we need to understand that which data is important when it comes to, let's say, serviceability as well as design criteria. So all these things do have importance when it comes to small structures as well as large structures, essentially. Apart from that, the next thing, the most important thing which I learned at JW is keeping everything very organized. So when you are working on large projects, let's say, so you have a lot of data: beam design, slab design, shear
Yeah.
wall design, foundation design. So if you have kept everything organized, then in that case, if you need to refer to something which you have done 2 months back, so it would be much more easier.
Right.
So that when while designing, I would say that keep everything very organized when it comes to the data which you have on your hands, as well as the data which you are filling or using for designing a particular structure. So it
Correct.
is easy to review the design as well, and later on to refer to it as well.
Right.
And the next thing would be that don't think you are wasting your time when you are doing repetitive design. As I've seen Kutumble sir's post on LinkedIn as well, that initially
Yeah.
people
Right.
are very, but I think that in my initial days at JW, I was designing only beams. So I for around 10 to 15 days I was designing 600 700 beams regularly. So my daily schedule was to punch in at 10 a.m. and start designing beams and punch out at 7 uh,
Uh,
after
beams.
designing 600 beams. So that was my daily schedule. So
Yeah.
it helps you a lot when it comes to larger and complex projects, because if, let's say, you have done 600 beams daily and for 15 days,
Yes.
so you have done a lot of beams to know that what type of behavior could be expected when it comes to, let's say, shear wall to shear wall beam, or shear wall to column beam, or a secondary beam.
Uh,
Everyone knows that, but these things help you a lot when it comes to, let's say, after 1 month you will realize that how far you have come from the that point.
yes.
So that I would say is that repetitive design is not wasting your doing repetitive design is not wasting your time. It is much more, I would say, that preparing yourself for the bigger things to come in future.
Bigger challenges. Yes, I agree. I
Yeah.
agree with this point actually. Dirty work. So I call this as dirty work. So doing dirty work always helps you in the long run. These days I have seen many people, they get disappointed very quickly. So the reason I wrote that post on LinkedIn a few days back was because I got a call, an engineer, fresh engineer. He has joined a big consultancy firm, only 2 months, and he was like मजा नहीं आ रहा है काम करने में. तो मैंने पूछा क्यों मजा नहीं आ रहा है, तो बोले एक ही जैसा काम है और बड़ा बड़ा नहीं है कुछ भी काम में, छोटा छोटा सब करने को दे रहे हैं. So I said that initially, as you rightly mentioned, that scale is not important initially. You should understand what is happening, and then you can use the multiplier effect to do bigger things quite easily later on. So yes, I agree with this point.
Also, what happens is that when you join any firm, so in structure engineering, every firm has a very different way of working. So
Yeah,
2 3 months you require to gel in and understand that what is going on, what how the modeling is being done, or how anything per. So after 2 3 months you will see that how far you have come, that
yeah,
you can easily understand that what is going on in the company, and you can easily gel in with everyone. So
yeah,
that also plays an important part, that if in 2 3 months you are loaded too much, or you are uh, supposed to do, let's say, a particular work, and you are also assigned 10 more tasks, so you won't be able to do anything very good. So that also affects your confidence and everything. So if you are
yeah.
doing one task and you are excelling at it, so it makes you much more confident that yeah, you can handle more
You
big
can
things
handle. Correct.
as well.
I agree.
So this is all from my side, and thank you everyone for listening to me.
Yes, good thoughts you shared. And if our audience have any questions for Parth, or if they have any questions related to the earlier two segments that we did, you can now ask them. So Atif was saying that do they still write objectives? क्या लिखते हो statement, career objective, the first thing they write in resume. I have never understood why they write that, and it is so complex English that they write, that if you ask the candidate to just explain what he or she has written in the objective statement, they will not be able to explain that. Looking to optimize my knowledge in a learning friendly ऐसा कुछ. So
Uh,
I have never understood why they write.
yes,
I
and
think that was long gone. I mean, I think they now don't expect you to write this stupidity. I don't know why still people write. So even if you ask the participant, or even if you ask the engineer just to explain their objective statement, most of them would not be able to do that. Anyway, so I think there was a question for you. Sandeep was asking. He was, I think, wanting to know your department, which specific team you are working, as I know that JW has separate teams.
I'm working with DD. I don't know that what is it is being called outside JW, but yeah, JW has three teams. One is for modeling, and one is for RCDC and safe, and third is for design and detailing. So I'm working for design and detailing.
Okay. Any other questions for Parth or me? You can put it in the comments. I will just take a few questions that were left during our earlier discussion. So Ashish ji was asking for pedestrian bridge, any particular loading criteria? If you are doing a pedestrian bridge, there is a IRC SP 56. So there's a special publication of IRC. You can refer that, or the standard loading criteria that you get from IRC 6. So these are the two uh, I mean, codal references that I can think of right now. Any other question that is remaining? I think Kashyap was asking loading. How have you assigned? Can you show? So loading, we in that bridge discussion that we just had, we had assigned the loading as uniformly distributed load (UDL). So we had assigned dead load of 1.8 kilonewton per meter. That was the finished loads, and live load of 9 kilonewton per meter. So if you notice, we have just taken one truss. In your bridge, you will have two such trusses connected by a cross member. But right now, for the discussion purpose, we have just taken one truss for analysis and discussion. Atif was making a point. Post graduation is actually the time when you know what should be your career path. Okay, I didn't know that during the post graduation because we hardly studied during our. I think these days postgraduate students, when I interact with them, they are much more smarter than we were when we did our masters. Because even after doing my masters, I hardly had any knowledge of any software. I didn't know any software. I think I just knew the working of STAT because that is what we had done in our BE. Other than that, I didn't know any software working, and it is only in the company when I worked that I got to know actual understanding of software. So actually working in a company teaches you a lot of things in your initial years. Sandeep was asking this question for you when you said that you do 600 beeps every day. So this was his
What do you
question
think
for you
about
then.
automation? Yeah, so automation, I would say that JW has a separate department. So based on those departments, you are assigned the work. So beam design is assigned to a particular department, and from that department, it comes to us before we have to we have to release the GFC drawing. So for that, we have to check the beams. Sometimes we have to check the beams, and if we see that something unusual we notice, so in that case we redesign the beams. So it depends that, like, let's say we have 600 beams to check. So from that 600 we have 100 beams which we see that reinforcement is something unusual, or in a particular structure, let's say that 100 beams are ductile beams. So for ductile beams we usually refer to ETABs for designing. So in that case we mark the beams and refer to ETABs for designing, and all other beams we don't, we just check, and based on the span and everything we check whether the reinforcement is okay or not.
So he is Sandeep was asking mainly this is true for big companies that how do you take decision in design when a separate person is making models. I mean, so because in big companies there are separate teams doing separate work. So what he is trying to ask that
How do you take decisions in design?
uh,
Separate. Yeah, so a separate person is making models, but the models is, I think, case of last. So, what the workflow is that basically, when project comes, so the project leader, or you can say associate level person, decides that what would be the framing and everything. After that, after the framing is done, we have to prepare a DBR. So in DBR, everything is mentioned. So he or she has not uh, does not have much, you can say, scope of taking decisions, engineering decisions,
correct,
because everything is mentioned in DBR. But if, let's say that, first they prepare the SLS model. So in SLS model, if the drift is exceeded, or let's say that there is the model irregularity is there, or a particular type of irregularity is there, so in that case they send us the SLS sheet, and we tell them that this changes should be made. So there is a lot going on between both the teams. So it is not like that a separate person is modeling, and essentially I am sitting in a different office or something like that. So we have same office and everything. So
correct,
it does not, yeah, there are some things, but I think that the system is good because the person who is modeling has modeled hundreds of models, so he or
building,
she has the speed, he or she has the speed to model it quickly as well. So that
yeah,
difference.
true. The next question is just give me a minute. Yes, so last question Kashaf is asking. I think this is for the bridge loading and support for truss. How you applied? It was 3D. How did you convert it in the? Yes. So I see. I had shown you only one truss. I had shown you only one truss, and in your actual bridge system, you will have two such trusses connected by a cross member. So for quicker understanding, for quicker behavior, uh, I just made one truss, converted the floor area into UDL, and applied it on that truss. Yes, Yogita ji is asking how is site visit managed and coordinated with the design team?
Okay, so site engineers, site engineer is separate department. So I don't know much about site team, but there is some criteria that if there are more than 60 site visits in a day or something like that, so then site visits are assigned to our team as well. But apart from that, I think everything is well managed, because there is a register or log or something like that which has to be filled by the site engineer and has to be submitted in the office or something like that. So
Now the
it was
coordination thing, if there is any query from site, how is that coordination done with the design team? That is what
so
Yogita is trying to ask.
okay.
Maybe during construction, let's say the construction has started, and if there are some inputs given by the site team, then how are they incorporated by the design team?
Normally, let's say that if I am working on a particular project, so most of these projects have project management consultancy. So project management consultancy has our number. So they call us directly if they have any issues in drawing. Uh, let's say that if they have any issues with the detailing which we have provided, so they call us directly and ask that whether this could be changed or not in the initial phases before GFC is released. Once
Okay.
GFC is released, and if there is a particular issue on site which has to be, like, it is not related to design, so in that case they mostly ask the project leader or some senior person, and those queries are not directed to us.
Okay. Good. Ashish ji is asking, who was your guide at SGSITS for
In
thesis? I think he
thesis,
is.
Professor Vijay Rode.
Ashish ji is, I think, from GSITS. So am I, but I did my BE over there. Okay, good. So I think we can conclude today's episode. So thank you, Parth, for taking out time and joining us on a weekend. I know you are a big football fan and you must be waiting to watch football after the episode. So thank you for taking out time and joining us. And thank you to everyone else for attending this episode on a weekend. Today we had to conduct this during a time other than our scheduled time. So next episode we will conduct it on time on at our regular time at 8:30. So that is all what we have for today. Thank you, and until next time, that will be around 24th of December, I think. Thank you and have a good time. Bye bye.